Very good morning. Thank you to the organizers for giving me an opportunity to speak on this new and interesting topic, oblique imagery for assessment as well as digital twin development. And once again, my name is Srini Damapuri, and I've been in the geomatics field for 30 plus years, primarily working in the areas of photogrammetry, LiDAR. That's the two core areas, and currently, I'm with the Sanborn as a vice president / chief scientist. So with this, let me get to the agenda. So first, I will give a quick overview about the company and also about the digital twin. Then how can we build a digital twin? What sort of source of data, specifically the oblique imagery? How do we capture the geometry as well as the texture? Those are the two important stuff for building any digital twin model. And finally, the most important thing is, building a digital twin is one thing. What are the use cases? That is what most of the people will be looking for. So I will talk few of the use cases of a digital twin. So a quick introduction about my company, which many people may be already aware of, is one of the oldest mapping company in the country. We have been in existence since 1866. Originally, it used to be in the insurance map, which even today people can see some of the insurance maps. So we have been in the aerial surveys since 1966. We have been constantly in sync with the technology development. We started the digital ortho production in 1988, and then in 2000, when the LiDAR was introduced, we were one of the early adopters of the aerial LiDAR technology. In 2004, we had a large format digital camera. From that, I think we have been collecting very big aerial images specifically for ortho as well as planimetric and topographic compilation. And I think very recently we started working on the HD maps. I will talk a little at the end on the use case of digital twin with regard to the HD maps. So as I said, we are a end-to-end mapping company. We have our own resources. We collect data, we process data, and we produce the deliverables. And also we have our own software team to develop software that will enable the product should be available to the clients in various forms. So that's very short about my company. As I said, we are a end-to-end mapping company. So regarding the resources, which is since we have a end-to-end mapping company, we have our own collection resources. We have 11 aircrafts, 3 ultracam large cameras. We have 2 LiDAR terrain mapper, and very recently we added one more Regal LiDAR sensor. In addition to that, we have all the necessary survey equipments for ground control and other things. And finally, the most important thing is with the resolution of the data is improving. Specifically, we are now collecting 3-inch data. You need to have a very good IT infrastructure. We have more than 4 petabytes of storage and more than 1,200 distributive processing CPUs to support our all production capabilities. So with that, let me get into the main topic. The very first question is, what is a digital twin? In a simplest way, the digital twin is a realistic representation of a physical object, product, entity, or a city. So it can be anything. It's a physical, it's a digital representation of a physical object. So basically, the most important thing about the digital twin is the last bullet. It combines multiple assets and their attributes together in one single model or a system. So that is the most significant aspect of a digital twin. But also the digital twin requires connection to the real world. So it can get the data from various sources, whether it's a video data or any other data. And so it should be connected to the real world. So that's the most important thing about the digital twin. So now this is an example. There are many types of digital twin. So you take the rightmost picture, which is an aircraft. So what you are seeing on the left-hand side is the actual aircraft, and what you are seeing on the right-hand side is the digital twin of the aircraft. So this example, it may not be applicable to us because we are all in the geospatial industry, and for us, anything we want to do should be geographically connected. So the slide I'm showing this to just to show you that, it can be products which need not be geospatially referenced, or it can be products which can be geospatially referenced. But I will confine my presentation to only those which are connected to the geospatial information. So the question, okay, we know what is digital twin. The next thing is, why is that we need to have a digital twin? So currently what happens is whenever people want to do some experimenting or testing, then what they do is do a physical prototype. So it takes some time. So that is how it is, the physical prototyping. Whereas with the digital twin, you can basically avoid the physical prototyping. So basically it minimizes the time, it reduces the risk, and it increases the operational efficiency. So it enables the smart cities in various aspects, including planning, design, maintenance, controlling, and analyzing. And almost in every aspect, the digital twin will be really useful. So the next thing is, how do we create the digital twin base maps? So basically we need to convert a remotely sensitive data into a digital twin base map. There are many existing sources of data is available. We all use the data day in, day out. So the next question is, what sort of data is available? What sort of data we should use? That is what we are going to cover in the next slides. So before that, I think, we know about the geospatial data. It can be aerial, it can be unmanned aircraft system, or it can be from the ground-based data. Let us take for the presentation thing, we talk about the Oblique Camera, and I think this is one of the state-of-the-art metric camera which we are using it. It has got 5 different cameras. One of the camera, the nadir sensor, sees vertically down, and then there are 4 sensors set at 4 different angles. So that way, for a given object or a given property or a given building, you can have a view of the building from 4 different angles. In addition to that, you can have a vertical angle also. So the Oblique Camera, it has more advantages. And using the nadir sensor, you can also create the ortho imagery, which we use it regularly. So we can create the ortho imagery also. So it supports 2 things. One is you can create the ortho imagery, or you can create the planimetric or the planimetric data from the studio images connected from the vertical camera. In addition to that, you will get the side view from the 4 different cameras: forward, backward, the left and right sensors. So that's about the Oblique Camera, and this is how the left-hand side picture shows. As the aircraft moves, there are 5 different pictures will be snapped at a given instant of time. So this is an example from the Oblique Camera. What you are seeing here is a vertical view of a particular building. The building viewed from one angle is shown on the right-hand side. So this is from the Oblique Camera, the same building from 2 different perspectives, you can see. And another important advantage of the Oblique Camera is that you can get attribution. You can see the resolution of the data, and basically you can read all the signs and the information what is available on the right-hand side of the photograph. So basically the Oblique Camera is also used to not only getting the spatial information, but also you can get some additional attribute information also from the imagery. So, what the next question is, so what sort of source data we can use? Primarily, you can use any type of source data, but we know these are all the different data sets that are in use. I mean, no, this is all purely aerial or unmanned. That can be another ground-based images also can be used. So we have the oblique imagery, the ortho imagery, aerial LiDAR, and the vertical imagery. What I mean by the vertical imagery is the stereo images through which you can collect 3D objects can be captured using the stereo images. So these are all the different types of data. And what is shown in the right-hand side of the slide is primarily using the input as a vertical imagery or the oblique imagery, what sort of outputs that can be created, including mesh models, 3D building model, a digital surface model, and digital elevation model, orthophotos, true orthophotos, and land cover maps. So these are all the different products that can come out of this from the imagery. So the basic ingredient for any digital twin model is the building. So when we talk about building, there are 2 different aspects of that, as I said earlier. One is the geometry, that's a shape, and the other one is the texture. So these 2 are the 2 important aspects of any building. So let us, in the subsequent slides, we will see how this geometry and how the texture can be captured from the images. So for the digital twin, I think, when we say building capture, this is how the industry handles the building capture with a level of detail, and it is LOD 0 to LOD 4. There are 5 different level of detail. So each one has got certain amount of information. As you go from LOD 0 to LOD 4, basically you are increasing additional information. So the LOD 0 is a 2D footprint, which means you capture day in, day out from the ortho imagery, the building you capture from the ortho imagery. That is a classic example of LOD 0. And LOD 1 is an extruded building, which means you bring the elevation information that can come from the stereo imagery, or it can come from the LiDAR, or it can come from the digital surface model. And then LOD 2 is the extruded building with roof type, and this is what the example shown here. And then whereas LOD 3 is a full architectural features, including doors, windows, everything, etc. And the LOD 4 is the interior modeling. So let us see each one. So as I said, LOD 0 stands for the 2D building footprint, whereas the LOD 1 is the with a single elevation. When I say single elevation, that means the highest point on the building, you give the elevation value either from LiDAR or from the stereoscopic coverage, and we call it as a sugar cube. And basically, what you are seeing here are the LOD 0 and LOD 1 data with the primarily no texture added to that. Whereas LOD 2, what you are seeing on the right-hand side is an extruded building with the roof type, whereas the LOD 3, as I said, is a full architectural features, including the doors, windows, etc. So this is LOD 2 and LOD 3. So this is about the geometry. Then the next question is about the texture. So the texture, there are different ways you can capture the texture. One of the simplest thing is nowadays texture library is available from which you can use the texture library. You can attach the texture to the building, or you can use the oblique imagery. That is what I will show you in the next example. Or you can use the ortho-rectified imagery. That is only for the roof, not for the side. If you want to see the texture of these buildings from the side views, you need to necessarily use the oblique imagery. And the geophotos is a ground-based photograph that we use to collect the buildings, and from there we take the texture. So what you are seeing on the right-hand side is a ground-based photograph. We call them as a geophotos. And what you are seeing here is the oblique imagery from which you got the texture. And whatever the right-hand side picture is a texture library, you can use what is available on the thing. Of course, the methods, though there are different methods there are various factors. Obviously, what is the collection method, cost, resolution, and visual quality. One of the important thing I want to make it clear here, the geophotos, the ground-based photos is really useful. But if you're going to study only very few buildings, some important buildings in a downtown area you want to study, then a geophoto will be a best example. But if you want to study an entire city, especially the downtown area, then the geophoto may not be a right option. Then you have to rely upon the oblique imagery, what is shown here in this photograph. So this is a texture library from which you pull whatever the texture that you think that is appropriate. And then what is shown in this slide is primarily, with the geophotos, what we do is we keep a regular camera and take the picture of the building from multiple angles, and then you create a texture from the multiple photographs, and that's the we have created a process what is known as the Geofeature Modeling, through which I think we can create the texture using the ground-based images. But as I said, the ground-based photos will be useful if you're going to have a very limited number of buildings, but if you're going to have a bigger area, then you have to go for an oblique imagery. And then so this is, so what happens is whether it is LOD 0 to LOD 4, you can add the texture. So, so the texture can be derived from the realistic imagery, like the oblique imagery, or it can be from the library, which is computer generated texture library. So one of the two things that you can do to get the texture. So this is an example of where the geometry of the building has been captured as well as the texture has been added to that. And this is how you see. And the another important thing is with this oblique photograph, the most important thing is you can also add the attribution to your place on the building. That's what I explained earlier. And the roof features will be textured with the ortho imagery, because the ortho imagery with that you can see only the vertical, whereas the side views will come from the oblique imagery. So the next one will be the LOD 4. That's the last one, and that is the ultimate, you can say, in which you not only capture outside the building but also the inside building. And what you are seeing is a video that we have captured inside a conference room. There are many ways you can do. We have developed some in-house technology. You can use some static LiDAR scanner mounted, and you have to take at multiple areas. You have to take scanning. What we have developed is a robotic based, so it is autonomous. You just allow it to run, and it will go on its own and capture the data inside the building. So there are different ways interior mapping can be done. One is the CAD building plan, digital blueprints, and modeling and LiDAR scanning. Invariably, the LiDAR scanning is one of the a complete method or a comprehensive method to get the full information. And this is an example of the interior scanning. What we're seeing is our corporate office building. That's where the entire production is being done, or rather majority of the production, because we have other offices as well. And as I said, what you are seeing, the subset here is the floor plan, and the Sanborn symbol is the robo that is actually moving and capturing the data. So what you are seeing here on the right-hand side, where I keep my mouse moving. So as I said, this is a robotic based, we call it as a spin technology, and it's autonomous, and it goes and captures the data, and then we have to take the data and process it and make it as an interior model. So the LOD4 is primarily both exterior as well as the interior. So you can definitely visualize the level of effort that is going to be involved in the case of LOD4. So with that, we come to the use cases. Why is that we need to create, or what are the areas where the digital twin will be used? Considering the audience, there are some of the examples I want to show here. Primarily, one of the important thing is the property valuation plus the risk analysis. That's one of the critical area. The other important topic is the NG 911, next gen 911 emergency response. That's very hot topic right now, especially in the county and state level. The other areas are very standard urban planning, land use optimization, transportation, energy consumption. That is another area I can show you a use case. And there are other areas like water, sewer, electric analysis, traffic, and weather. But the most important thing is I want to emphasize on the NG 911 as well as the property valuation and risk analysis that I think that will be in line with your day-to-day work. The other thing is, of course, the autonomous vehicle driving. This is an area where we have been working on. Our job is primarily to create the maps, what we call it as high definition maps. We are using the Google Maps or other things, or all navigational maps. So we have to use our intelligence, but whereas the HD maps will have every information built in, including the stop sign, everything, so that the car can make the decision on its own for autonomous driving. So this is the property valuation example. What we have noticed here is, you can, the users are, primarily the occupancy information, historical occupancy information. What about the rent history, the location discovery, as well as the virtual tours. That's the most important thing, the virtual tours. So basically, because it's used as a virtual tour, it can be, it's a visual executive decision support for people to make the call. And also it enables the better property return on investment, as well as lower the cost where possible. So what you are seeing on the left-hand side is the different graphs, showing overall vacancy rate, what are the rent trends, and those type of information. So this is primarily, we see one of the important application of the use case for the digital twin, primarily in the property valuation. Once we talk about the property valuation, the next thing is obviously the risk analysis. So given a property, people always talk about what is the property hazard, in terms of flood or in terms of any other natural the disasters. And so this is the digital twin will be primarily useful in the case of the risk analysis. And also it is useful in terms of portfolio value analysis, primarily, what is the value of the property based on the location, proximity to various features, and so on and so forth. The next application, the use case is the next gen 911. And this is one of the hot topic right now. It's a 3D, what is the use of 3D digital twin? Primarily, what we are expecting is it will have the address location data. The most important thing is with the digital twin, you can have a locator person both in horizontal and vertical direction. That means exactly if it is a building, and within the building, multiple floors, multiple rooms. And with the help of the digital twin, primarily, you can say this person, whoever has made the call, is at the XYZ location. So that is what we see as one of the real use case for the next gen 911. So this is one of the, in the country of Qatar, we did a digital twin a couple of years back. And what you are seeing on the video left-hand side is primarily how the features have been captured and then attributed, textured. And you can see the video clearly, the digital twin of a particular site within the country of Qatar. And the other one is the energy analysis. This is a term people use in the energy sector, the insolation primarily. With regard to sun, you calculate various parameters. What is the building height? What is the roof slope? What is the compass direction and the surrounding buildings? What is the shadow and so on and so forth. So this is something we have noticed that, in the case of energy analysis, or this digital twin has got a definite potential to be used. And as I said, the autonomous driving earlier, we make HD maps. Unlike the regular navigational maps, I think this will have every piece of information on the road, including the road markings, signs, poles, sidewalks, crosswalks, everything. All the information will be built within the HD maps. And we do see the digital twin has got a very good potential in the case of using the HD maps. Finally, the indoor mapping, I showed you a couple of examples, and I think the most use cases will be the life-saving emergencies and evacuations. And finally, the emergency response or the law enforcement, that's another area where the digital twin will be really useful. And I think this is my last slide. I think, as I said, the digital twin is a combination of everything in one single system or a model. So there is a lot of scope exists to bring more geospatial data and improve the model. And we do see it has got a lot of potential in the future. I think with that, I believe this is my last slide, and I can address a few questions if time is available.
All right, does anybody have any questions for Mr. Dharmapuri?
Yes, sir.
We have one from Cynthia Rice on 3D maps. How real time could this be? So in case of a permitted parade or snow routes, how easy would it be to change?
See, the moment we use the real time, then the question is how quickly you can collect the data and how quickly you can process the data. So that is what the challenge is. Okay, you can have a fixed sensor, so that data will be continuously coming. So the data acquisition part, partly you can solve. But the real challenge is once the data reaches you, how quickly you can process, whether whatever be the tool you have got, whatever be the automation you have established, whether you can make it. So in my view, at this time, I will be a little cautious. I will tell it's a near real time, so that there is some time is available for you to process and get some meaningful information out of the data.
Well, from my perspective, I working for the state for several years and working with a few folks down there with imagery and LiDAR. This is an extremely interesting topic to myself, and we've recently acquired here at Metro some road level asset LiDAR that I'm hoping to have some time to fool around with. So this has been a very interesting topic to me. So does anyone else have have any more questions for Srini?
Srini, talking about storage and perhaps in the cloud and uploading data to the cloud, is that a problem when you have this many, like orders of magnitude of data now, petabytes probably, right?
I mean, at this time, the cloud is a very viable option. There is no question of that. But the only thing you need to be, it depends purely on what sort of processing you are doing. Whether you want to do the processing on the cloud, then you need to take one step back and see what is the efficiency you are getting if you do the processing on cloud and when you do the processing on your own server. So that's something that purely depends on what sort of processing you are going to do or what sort of information you are extracting from the geospatial data. But I think the cloud-based thing, once the data is processed, I think, for storage, retrieval, archive, we extensively you rely upon the cloud-based storage. And we have developed some tools, software tools for storing and retrieving the data, multiple data, because what happens is it's not only one-time collection, you collect data so many times periodically. So then over a period of time, you will have so much data. So you need to have a very systematic way of, quickly identifying a data. For example, you want to go back to 2018 and pull some data, then you should have, a mechanism by which you can immediately see the data and retrieve the data and download the data and go from there. So those are all the things I would say cloud is the best. But the moment you get into the processing on cloud, I think that's something needs some little bit of, discussion as well as analysis and that type of thing.
That's an excellent segue to our next question. Mike Douglas would like to know, beyond collection, what are the long-term implications of storing and compressing that much data? You just mentioned the cloud. It sounds like that may be the best method. Srini, did you hear my question?
Sorry, sir. What's
I'm sorry, no, it's fine. It says beyond collection, what are the long-term implications of storing and compressing that much data?
As I said, no, I mean, there is no long-term implication. As I said, we, because of some of the state agencies have collected multiple data sets over a period of time, we have developed some tools. And I think there are, and especially in the case of LiDAR, some excellent compression mechanism is available. And in the same way with regard to the images also. So I think, we can organize the data in such a manner. If you are having some 6 or 7 different data sets for the entire state, it may be imagery, LiDAR, or even both, you can store them, index them properly, so that I think within a few clicks, you can identify the area where you can go to the area, select the area of interest, pull the data, whatever the data you want. It can be 2008 or 2012, and download the data, and you can go. So I think that is where I think the cloud-based storage is really, really useful. And we have built some good tools in order to enable the bigger agencies who are collecting large volume of data. Not necessarily the government agencies, even some of the utility sector people also, they collect a large volume of data, and we store them depending upon the case, if it is a cloud or it can be a server, depending upon the case. But that is true. That is where things are moving. I don't see any long-term implication, because the things are, especially with regard to the compression as well as the indexing the data, a lot of things have happened, and I think we get excellent results. And I'm sure that there are a lot of people have reported excellent results in similar type of case study also.
Well, that's an excellent presentation, Srini. Just to reflect what's in the chat room, a lot of folks are very encouraged by the work and its value to them. So if you take a moment, if anybody would like to reach out to Srini and discuss this further, I'm sure he'd be more than willing. You can see his email address at the bottom of his page there. So with that, without further ado, Srini, thank you so much for your time, sir, and joining us. Hope to see you again.
Thank you very much.
We will move on to detecting Kudzu infestation utilizing satellite imagery and GIS with the folks from Murray State University. And I'm going to turn the moderation duties over to our friend Demetrio. Demetrio, sir, you are muted.
Of course.
Happens to us all right away.
Thank you. I appreciate it. Of course, that's the one thing that we all do. I have the pleasure to introduce the next speaker, who is Clint Cornelison. Cornelison or Cornelison, I don't know the pronunciation exactly. He's a GIS and remote sensing undergraduate student at the Department of Earth and Environmental Science at Murray State University. Clint is also, very important, a recipient of the 2021 Camp Scholarship Award. So his paper is Detecting Kudzu Infestation Utilizing Satellite Imagery and GIS. Clint, it's all yours. I guess we have Haluk, Dr. Chetin.
Yeah.
Hi, Haluk.
Hi. Clint is not online.
I did not see him on the list of on the participants box. I don't see him.
Okay, probably thought it was at noon, I guess.
Or or Matthew Myers, right? So you're going to present?
Yeah, probably I will do that. And
Thank you for doing that.
yeah. Um,
You need to share your screen. There you are.
okay. Here we go. So the purpose of this study was to initially look at different species, invasive species in Kentucky especially, and and one of the, I guess, most important species that really widespread in Kentucky especially is Kudzu. And so uh, this study was sponsored by Kentucky NASA, KSGC, and so several students work on this, including Matthew Mayer and Clint. So in terms of I guess initial thing that we need to was to find out um, where the Kudzu spread was, and we examined all the locations and known locations. So this is just showing you the extent of Kudzu density 2020 based on. And as you can see, mostly south eastern region. There are a few locations in the northwest, and so when we look at the predictions, what's going to happen in 2040, between 2040 and 2060. Really wide spread, including some of the Midwest states, and as you can see in the West, much more area covered by will be covered by Kudzu, and so this is one of our test sites in Hickman County. One of the westernmost, county. And in the background, this is Obion Creek, meeting Mississippi River. It's, close to the, Mississippi River. And as you can see, Kudzu not only covers the, close to, low slope areas, but also, trees everywhere. And even, I have some close pictures, but probably, he did not include that. But, even it covers some of the abandoned, houses and barns. So this is really an invasive, species. And so this was, one of the largest sites that, we, managed to find. And so initially we used Landsat 8, satellite data. And by the way, this image is from DJI, Phantom, 4 that we have. So and very high resolution image. Pixel size is like 3 centimeters, and so in terms of just this site, we selected. There are like approximately 15 Landsat pixels covered by this Kudzu site. And so initially we used an unsupervised classification. ISO data methods was the algorithm that we used, and we initially selected 127 classes. So after the classification, of course, there were really false alarms as well. So so this is one of the results, and the Kudzu areas are in yellow color, and so of course there were some clouds which caused some problems, and so just the ISO data classification itself wasn't really helpful. There were several false alarms, and so what we did was we included digital elevation model and texture analysis. So we extracted slope maps, and so then we ran texture analysis, and so basically these are some of the confirmed Kudzu sites, and so just Wycliffe area. So we just here it's just overlaid with confirmed sites. This is the largest site in Hickman County. There were several, but at the same time there were some false alarms, and so the next step was to select other areas, and so this is just the framework of our work. So including field work, remote sensed data, remote sensing techniques, and geographic information systems, including digital elevation models and soil surveys, and so the purpose was to integrate more ancillary data to be able to more accurately pinpoint those infested areas. And so in terms of remote sensed data, in addition to Landsat 8 satellite data, we use Sentinel satellite data, European, which has much higher resolution and more bands. So Clint got this, I guess, from Google Maps, street view. So you can see some of the infested areas, and in fact, I collected some photos. I did not have this location, so that's why he included that. So so basically, what we did was then we focused on Western, Kentucky. So in terms of some of the areas, there are really big sites in McCracken County, especially near Paducah and Marshall County, and several in Callaway County, and in land between the lakes area. And so we the second step was to focus on a little bit larger area. But ultimately, this is an ongoing project. Ultimately, we would like to look at entire Kentucky, especially eastern part has really large infested areas, and so these are some of the examples of where Kudzu could be found, and so Paducah area, there are large tracts of Kudzu infestation. So so we also just basically created much larger elevation models, and then we looked at some of the characteristics of topography where Kudzu is found, and so we will look at just very detailed for all the at the confirmed sites, what the slope values were, and this is based on new versus older growth areas. So new growth is in blue color. Older growth is in orange, and in terms of looking at all this, of course, it's all over the place, in terms of slope, all the way from flat to even 30 degrees. But majority of the Kudzu locations had slope values between around, really, when we look at the median, probably it would be around 3-4 degrees. And so this map shows mean slope just basically 3 degrees, and there are many locations, of course, but in terms of course, just as I said, this is an ongoing project, and also when we include Eastern Kentucky, that figure might change. So similar to what we did for using Landsat 8 data, we use Sentinel-2, and on the left, what you are looking at is a regular false color composite of Sentinel-2 image of our western study area. And so similarly, we ran unsupervised classification, as well as Matthew used a supervised approach, but he was not that successful in just delineating Kudzu. There were many false alarms and mislabeled areas. So just looking at this, just location-wise, this is Kentucky lake area here, land between the lakes. So it's more like near Kentucky lake here, land between the lakes here, but probably label might be a little bit misleading. And these are different scales, so focusing on this area here, and then just much smaller area here. And these are the Kudzu locations that we managed to extract. And so by using mean slope, of course, I mean when we look at some of the areas that did not have Kudzu, still had that mean slope values, and but these are all the locations that we could come up with. So Clint is still working on this project. So so here are the known Kudzu locations, along the Highway 80, just then between the lakes, and and then near Cadiz, there are several sites too, and so these are the Paducah locations, and so of course just sometimes when we look at just the DEM and slope information, it doesn't tell us a lot, but when you combine with classification of remotely sensed data, it really helps. And but still we are having issues. Clint overlaid some of the known locations with on top of classification results. So these are the known locations, and as you can see, he managed to basically find those areas, and there were additional, of course, pixels, and so as you can see, this is higher resolution image, aerial image. So these are the sentinel pixels over the aerial image, and so these are some of the other locations, especially near some of the highways and interstate. And then, as you can see, he could locate some of them, but of course there were some probably false alarms too. But this is another example. Really, this just pinpoint. He could pinpoint the location along the highway, and so and more examples. And just classification versus known locations, and so this is a known location. So and there's of course there were some vegetation species that really mixed with the signatures of Kudzu. So I mean, Kudzu itself is a vegetation type. So so in terms of our Hickman study, basically just the classification itself did not really work well. There were too many non-Kudzu fields, but when we included ancillary data such as digital elevation models and slopes and texture analysis were run and included integrated with the classification results, then that approach really eliminated some of those non Kudzu fields, but we are still having issues. So our next step is to include other ancillary data such as GIS data such as soils and other data that we are considering. So as I said, this is an ongoing project, and so ultimately what we would like to do is look at the influence of urbanization and other factors, and such as climate change. So another student of mine, graduate student, is working on those issues, and to find out if there are any correlations between Kudzu infestation and those changes like land use, land cover, change, and so in terms of this study, it's supported by NASA Kentucky Space Grant Consortium, and so there are other studies, ongoing studies that would probably help this project too. So, and Clint has been working for me for a while, and so has met, and so unfortunately probably I think maybe it was my fault. I look at the schedule, and so for noon I guess, but it's Eastern time, so probably he missed that because of that. I did not have time to call him. So, but so yeah, thank you for attendance, and just if there are any questions, I would be happy to answer.
I have a question, Dr. Chetin, regarding the you're using leaf on only imagery, or multi-temporal, like leaf off, maybe spring imagery from Landsat, to check and see what those sites look like in the winter.
In terms of let me switch. So in terms of imagery, as I mentioned, it was September image for Landsat. So I think, yeah, it's a very good question, because Kudzu actually after leaf off, basically you can still find Kudzu sites. So it's another aspect of this study to look at multi-date imagery, including just right after during the leaf off season, when there are a lot of changes. So yeah, definitely. I mean, Kudzu still stays around for a while, and then basically becomes green earlier, and so but time is really critical to sometimes pinpoint those locations. So but this is our initial take on this project. So just we want to use full-blown spread, and see what kinds of challenges we would face. So but yeah, it's a good question. It's sometimes it's time critical data, can be really helpful. So
I know that you're the director of the Hyperspectral Lab. Any plans on creating a library for Kudzu? Any spectral library?
Yeah, I mean, especially like for land between the lakes, I have very detailed species hyperspectral library, and but in terms of, I think, data that we like to use, I mean, we are looking at regional data, and but if we focus on much smaller areas, probably hyperspectral data would be really helpful, right? So unfortunately, we had I mean, I started with Hyperion, satellite hyperspectral sensor, but we don't have too many scenes for Kentucky. So I have a few scenes covering like land between the lakes and a couple other areas, but yes, definitely hyperspectral data would be, would, improve our results.
Do you think that with the advent of hyperspectral cameras mounted on drones, you may have another opportunity to study the same systems with better data from higher spatial resolution and such? I know it's emerging technology, but do you think that will?
Sure. Yeah. I mean, but it would be real localized study. I mean, our purpose was to look at, statewide. It's basically a statewide project. So, and of course, there are many limitations, and we are also planning to use, other types of data, including radar data. So, and then in fact even LiDAR. So we talked about that too, right? You mentioned hyperspectral LiDAR, and so it's just I think the technology is getting there. So,
any questions for Dr. Chadden on this presentation, please? Just unmute yourselves and go ahead. I think that you can unmute yourself, if I'm not mistaken, right, Scott?
You can.
Well, going once, going twice.
I had one question. I have never looked it up, and this is going to sound ridiculous. And maybe you answered it already, and I just didn't hear it. Is Kudzu edible?
I'm not sure.
I've always heard that Kudzu was consumable.
Yeah, I mean, sheep and I guess goats, especially goat, just love those. So I guess some of the farmers they use animals to, if they can eat it, probably can eat too. So, but I wouldn't try. So.
Well, truth be known, I think it was a threat in my family when we would travel and we would stop and say, well, we're hungry. And my dad would always say, well, we'll stop and eat the kudzu if you like. So that's why we always were given that. So anyway.
Yeah, there are subspecies. I mean, same like mushroom, so, and even if there are mushrooms in the area, I mean, the poisonous, they can actually, poison you, just, how, sometimes poison spreads. So that's why, but I mean, the animals love them, so all the, Kudzu species, so.
Well, I appreciate your answer. Thank you, sir.
Sure. So, yeah, my pleasure.
Being 12:30, I'm going to hand it over to Scott Stepro, the super moderator.
I'm going to slide it right on into Andrew's lap.
Okay. So break is coming up, and then the business meeting, Andrew, is at 1:30, I presume. Go ahead.
Yep, that's correct. So the business meeting is at 1:30. If everyone's invited, it's going to be super enthralling. You'll get to see a bit how the organizations ran. And then right after that is our scholarship awards. So super excited about that. But yep, lunch break now. Stretch your legs, get some lunch, and we will see you back at 1:30. As a reminder, use the agenda for the room link, and looking forward to it. See you all then. Have a great break.
Thank you for attending.